Welcome back, everyone. Today we are going to go ahead and finish up Unit 3.11, which is all about the reciprocal trig functions, secant, cosecant, and cotangent. We handled the graphs yesterday of the parent functions, right? Well, now we're going to do some basic evaluation without memorizing the unit circle, so you know I'm going to be drawing, right? Because I don't have the unit circle memorized. Gonna have to draw some stuff. Grab some colorful pens here because everybody likes colors. All right, secant of 13 pi over 3. First of all, secant is the reciprocal of what? One person, two people. Cosine. Lots of people would hope that lots of people could tell me that secant is the reciprocal of cosine. So since cosine uses the sides x over r, secant is going to use the sides r over x. Next, we would need to know where we are. Well, the way I do this is I ask myself, what is 13 over 3 as a mixed number? So I go, all right, 13, I don't want to use black. 13 divided by 3 is 4 1/3. That means 13 pi over 3 radians is 1/3 of a pi past 4 pi. So what is 4 pi coterminal to? 0. So this is actually coterminal to 1/3 pi, which would be in quadrant 1. Because this here is 0, and then again 2 pi, and then again 4 pi. Picture not drawn to scale, but a pi over 3 would be in quadrant 1. So since it is an over 3, what is the size of its reference angle? 60 degrees. Lots of people should be shouting out answers, not just one. But this is a 60-degree reference angle. That makes this a 30, 60, 90 right triangle. The side across from the 60-degree angle, we're calling it a square root 3. This would be a 1. This would be a 2. So secant of 13 pi over 3 is r over x, 2 over 1, and 2 over 1 is just 2. There. Easy, right? Not too bad. I honestly think that the hardest part is, do you know where that triangle is going to be drawn? And as long as you're comfortable using mixed numbers, you're going to be all right. Cosecant. Cosecant is the reciprocal of which trig function? Lots of people, please. Sine. Cosecant is the reciprocal of sine. Sine uses y over r, so cosecant is going to be r over y. 17 over 4 as a mixed number. 4 goes into 17 4 times with the remainder of 1. So that is 4 1/4. Well, we've already said that this is 4 pi. So 1/4 of a pi later is once again in quadrant 1. And if it is a pi over 4, what is the size of its reference angle? Lots of people. 45 degrees. Side lengths associated with a 45, 45, 90 would be? Come on, people. 1, 1, square root 2. Come on, guys, get with the program here. So our r over y is root 2 over 1. Ta-da. All right. 9 pi over 2. Oh, wait, I'm not there yet. Cotangent. Cotangent is the reciprocal of tangent. Tangent's sides are y over x. That makes cotangent x over y. 9 over 2 is 4 1/2. Oh, it's an over 2. So where am I going to find this? On the y-axis. This is one of my quadrantals. It's specifically the y-axis. Positive or negative y-axis? Positive, because this again is 4 pi. So if you go half a pi past 4 pi, you'll be here. This is our 9 pi over 2. We don't have a triangle, but we do have a coordinate. And if this is my unit circle, the values there are 0 and 1. So my x over y here is just 0 over 1, or 0. And lastly, secant. We've already said secant is the reciprocal of cosine. Cosine is x over r, so secant is r over x. See, I don't have that memorized. I have to work my way through it every time, but whatever. R over x, and that mixed number, negative 17 over 6. 6 goes into 17 only twice. Negative 2, and that'll be a remainder of 5. So we have negative 2 and 5/6. So what is coterminal to negative 2 pi? 0. So imagine you were here before I draw it. This is 0, but then it's also negative 2 pi. If I go another negative 5/6, which quadrant am I going to land in? Quadrant 3, because it almost went to negative 3 pi. So this is negative 3 pi, so negative 2 and 5/6 is in this quadrant somewhere. So I'm only going to draw quadrant 3. Picture not drawn to scale, never is. And since it is an over 6, what is the size of my reference angle? 30 degrees. What's always across from a 30-degree angle? A 1. But I'm in quadrant 3, so Nyla says it's negative. She's right. That means this is the root 3 side, but since it's quadrant 3, it's also negative. Radius is always positive. Secant is r over x. Oh! Okay, we're going to have to rationalize this denominator for the AP exam. So secant here is 2 over, well, negative, and we'll say 2 over root 3. If you multiply the top and bottom by the square root of 3, we will get, negative 2 root 3 over 3. There. So could I have my unit circle memorized? Sure, I could. But it's hard. Unit circle's got a lot of information. There's a lot going on. I can't do it. I mean, maybe I could. I'm sure if my life depended on it, I could. I don't want to. I don't want to. Do you think that you are comfortable enough, though, to evaluate all 6 trig functions at any of the special angles? Do you think you can pull that off? Okay. Yeah, only the special ones. If they weren't special, you're going to have to use a calculator. Boop. The reciprocal identities. Cosecant theta is the reciprocal of what? Sine theta, yeah. So cosecant theta is 1 over sine theta. Secant theta is the reciprocal of? It's the reciprocal of cosine theta, so 1 over cosine theta. And cotangent is the reciprocal of tangent theta. So it's the reciprocal of tangent theta, so it's 1 over tangent theta. These are the reciprocal identities. The quotient identities are asking you what fraction of trig creates tangent theta. Tangent is sine theta over cosine theta. Well, reciprocal just flips a fraction over, so the reciprocal of sine theta over cosine theta is cosine theta over sine theta. Remember, y over x, x over y. That's it. Not too bad, right? Okay. What if I give you a random coordinate and I tell you it is on the terminal side of an angle? That coordinate is negative 2, 5. Which quadrant is negative 2, 5 going to be in? Yep, quadrant 2. I'm going to go ahead and draw it over there. Whoa, I drew that really crooked. Negative 2, 5. How do I find the hypotenuse of that triangle? Pythagorean theorem. So x squared plus y squared equals r squared. That's 4 plus 25 is r squared. Now r is always positive because it's the radius of a circle. Take the square root of both sides and you get that the radius is the square root of 29. Now that we have x, y, and r, we can find the value of all 6 trig functions. Yep, all 6. Let's start with sine. Sine of theta is y over r. So 5 over root 29. Ooh, better rationalize that denominator. 5 root 29 over 29 is what you will get if you multiply the top and bottom by root 29. If you know sine of theta, you also know cosecant theta. So just flip this over. Root 29 over 5. Cosine x over r, negative 2 over root 29. Got to rationalize that denominator for AP though. So negative 2 root 29 over 29 is what you will get when you multiply the top and bottom by root 29. If you know cosine theta, you also know its reciprocal value, secant theta. I'm going to flip this one over so I don't have to rationalize the denominator. Negative root 29 over 2. And lastly, tangent and its reciprocal. Tangent is y over x, negative 5 over 2. Flip that bad boy over to get to cotangent theta. Negative 2 over 5. This is pretty easy, isn't it? I think it is. I think it's pretty easy. Skirt! I've given you sine and cosine. Well, not me, but this question's given you sine and cosine. That means you instantly know x and y and r, except for, these are rationalized. I mean, we're trying to find the exact values of the other 4 trig functions. We can easily get cosecant by flipping this over and secant by flipping this over. But then I'm going to have to rationalize the denominators again. And tell you what I'm going to do. I'm going to write sine and cosine in their unrationalized form. So if I unrationalize it, essentially divide the top and bottom by root 13, you will get 2 over root 13. Cosine theta, divide the top and bottom by root 13, and you will get 3 over root 13. Oh, all right. So my x isn't 3 root 13. My y isn't 2 root 13. My r isn't 13. My x is 3, my y is 2, my r is root 13. There. Cosecant theta, flip that over, root 13 over 2. Secant theta, flip that over, root 13 over 3. Tangent theta. I think I was intended to do this over this so that you can see everything cancel out, but I would rather do it this way. I think this is more efficient. Tangent is y over x. Looks like 2/3 to me. Therefore, cotangent theta is 3/2. I just feel like that's more efficient. I don't want to use the, what are they called? Quotient identities? Yeah, I don't want to do that. Quotient identities. I'd rather just know my x, y, and r. And the last skill, I believe, well, no. The last two skills, finding equations of graphs and graphing things that have been transformed. Equations of graphs. I don't have much memorized. I really don't. So if you give me a reciprocal function and ask me to find its equation, I really do, if it's a secant or cosecant, I really do have to draw in the reciprocal function as a dotted line. So I'll do that in red. If you had to write the equation of that red line, based on the fact that it's right here on the y-axis, would you want to say sine or cosine? Cosine, and would you say positive or negative? I would say negative as well. So if you start it right here, you're looking at a negative cosine wave because this is a minimum. Let's see what kind of transformations we have. Max to max, min to min. That's period length. So for the red curve, from here to here, from negative pi to positive pi is, oh, that's 2 pi. The period of that red curve should be 2 pi. There is not a horizontal dilation. The maximum of that red curve is 1. The minimum is -1. That means the midline of the red curve is the x-axis. There's no vertical shift. And that means the amplitude of that red curve is 1. There's no vertical dilation. So no horizontal shift, because we said start it here on the y-axis. No vertical shift, no horizontal, nor vertical dilations. There is literally one transformation. That's the red one. It's negative cosine x. Then what is the easy reciprocal function equation? The easy one is, what's the reciprocal of cosine? Secant. Negative secant x. That's the easy answer. Well, it does say to write two different equations. There's our secant answer. Let's get a cosecant answer. Cosecant would be the reciprocal of sine. That means we would need to look at this thing and figure out a sine model for it. Let's do a positive sine model. Where, and by where I mean what x value, at what x value would I need to start my positive sine model? I could start it here, or pi over 2. So either one of these works as a starting point, and since this is less to right, I want to use that one. There's absolutely nothing wrong with using that as a starting point. This is just I don't have to write the negative or the 3 if I write that. But if I start right here, I have a positive sine model. And the reciprocal of sine would be cosecant. Ta-da! Not bad, right? If your sine and cosine skills are really good, then your secant, cosecant skills are really good. You just write the other function. I mean, like that's literally it. Now, tangent and cotangent is going to be a little bit different, right? It says write two different equations using tangent and cotangent and tangent. So based on its shape, and by that I mean a decreasing function. Would you want to say that is tangent or cotangent? Is this what tangent looks like or cotangent? This is what cotangent looks like. Cotangent is a decreasing function. Tangent is an increasing function. So based on the fact that it looks like this, I want to say that this is a cotangent model. We could write it as a tangent, obviously, and we're going to, but it looks like cotangent. Cotangent is side lengths x over y. So if you're on the unit circle, the only place where you have, well, let's just do it like this. If you're x over y, and you are here at 0 radians, you have no y value. So cotangent is undefined on the y-axis. Tangent is 0 on the y-axis. Cotangent is undefined on the y-axis. So if you go back to where we just were, there is supposed to be a vertical asymptote on the y-axis, and there isn't one. It's here. So I would argue that this thing has been shifted left, whatever this value is. Well, what's halfway between 0 and negative pi over 2? Negative pi over 4. Let's track down period length. The length of this thing's period is, I'm just going to count tick marks. 1, 2, 3, 4 tick marks. And if you start at 0 and go 1, 2, 3, 4 tick marks, you see that 4 tick marks makes up a pi. So the period is pi, like it's supposed to be. Tangent and cotangent both have a period length of pi. The inflection points are located right on the x-axis, like they're supposed to be. That means there's no vertical shift, and the fact that the period length is appropriate means there's no horizontal dilation. And lastly, you can see halfway between the inflection point and the asymptote, I only went up 1 and only went down 1, like I'm supposed to the positive 1 and the negative 1. So there's no vertical dilation either. The easiest way to describe this thing then is y equals a cotangent graph that has been shifted left, pi over 4. That's the easiest way to do it. Slightly more difficult because you have to remember that cotangent is undefined at the y-axis and is decreasing. Tangent is 0 at the y-axis and increasing. So you do have to memorize the shape for those two, the shape, just like you had to do for sine and cosine. Now if we're going to call it a tangent graph, what are we going to have to do? Because tangent is an increasing function. It's, well, first, negative. We have to reflect it. And there will also be a phase shift of some sort. So first, let's write it as a negative tangent graph. That's going to at least make it decreasing. We know it won't have a horizontal stretch or shrink. It will not have a vertical stretch or shrink. It will not have a vertical shift, but there will have to be a horizontal shift because tangent is supposed to be 0 on the y-axis. This thing is 0 right there at pi over 4. So which way did it shift? Well, it shifted right, pi over 4. So if you're going to describe that, you say that is a horizontal shift of negative pi over 4 units. No, that doesn't make sense. No, you say it's a horizontal shift of pi over 4 units, but that means to the right. It's written horizontal inside opposite. Right. So it's going to be, it's going to say this. Right, but you describe this as horizontal shift of pi over 4 units. Right, but that's confusing. So we have to, okay. There it is. Hey, I got a question for you guys. How far apart are positive pi over 4 and negative pi over 4? Half a pi. And what is half a pi in degrees? What is it in degrees? 90 degrees. Huh. I wonder why 90 degrees. I wonder why there's a 90-degree difference between the two. Tangent and cotangent are complementary functions. Just like sine and cosine are pi over 2 away from each other because they're complementary functions, tangent and cotangent are pi over 2. Wait a minute. Secant, cosecant Those are pi over 2 away from each other because they're complementary functions. That's what co means, complementary. And it'll always be pi over 2 away from each other as long as there has not been a horizontal dilation. Let's wrap it up. Graphing with transformations. I don't know what any of this crapola is. I'm not going to bother. I'm not even looking at any of that, okay? None of that's important to me. I don't have any of that formula stuff memorized. And you shouldn't either. It'd be a waste of your time. If you're comfortable with the way that I did it, we're going to write this as its reciprocal function, which would be sine. And I guess I'll do that in blue. Y equals 2 sine of x minus pi over 2. What is the period of this equation? 2 pi. So we have a period of 2 pi. Because it would have been 2 pi over b, but our b value is 1. Where does this thing start? Pi over 2. It's what makes the inside equal 0. Pi over 2. There is no vertical shift. So sine graphs, where do they begin? Minimum, maximum, or midline? Midline. So this thing is going to be on its midline at pi over 2, and since there's no vertical shift, that midline is the x-axis, so I'm on the x-axis. A period length later, I'm back on the x-axis. Let's see, 2 pi was, I'm going to see how long 2 pi was. 1, 2, 3, 4, 5, 6, 7, 8. So 2 pi is 8 tick marks on this grid. 1, 2, 3, 4, 5, 6, 7, 8. There we go. And if I go back 8, 1, 2, 3, 4, 5, 6, 7, 8 puts me right here. So that is beginning to end. A sine graph is shaped, a positive sine graph is shaped like this. So halfway between the beginning and the end, we'll be on that midline again. And we're going to go up to a maximum. Our amplitude of this thing is 2. I say that's enough. There is my ghost reciprocal wave. Why bother? Because every time the reciprocal function sine is on its midline, cosecant will be undefined because that is where the trig function has a value of 0 and we can't divide by 0. So every time sine is on its midline, cosecant is undefined. And we saw yesterday that basically all you do is grab the curves and flip them upside down. And while we're here, you know what I think we should do? I think we should write a secant model for this graph as well. Good news. It's going to have a 2 in front and no number at the end and no number in front of x. We already know all of that. Secant is the reciprocal of cosine. Looking at the blue model, where would you like to start your cosine model? I would start it right there at 0, -2. And that's a minimum. So what kind of cosine model are we talking? A negative cosine model. So we could say this is a negative cosine graph, the blue one, with no phase shift, which means we could also say that this green one is a negative secant model. Oh, I forgot my 2. With no phase shift. So -2 secant of x is this graph. This is power, folks. Being able to do that, be able to move between the two, that's a big deal. Any questions on it? Nope. All right, then the very last example, boop. We talked about this before the last test, but you should not be trying to graph trigonometry of any kind if the argument is not factored. You want your argument factored so that there's no number in front of x. And the reason why is because you want us to be able to see where you should start. You want to see what that phase shift is. So we are going to take this 2 and divide it away from the 2x and the pi, and it gets us to here. Once again, though, it's tough for me to graph reciprocal functions, secant and cosecant. So I'm going to call that, well, I'm going to graph the reciprocal negative cosine of 2 times x minus pi over 2 minus 1. I'm going to graph this cosine wave as a dotted line. I see its midline is y equals negative 1. Where are we going to start this cosine wave? What x value? Pi over 2. And it's a negative, so it starts at its minimum. And the amplitude is 1. So at pi over 2, we go down to a minimum, which will be 1 below the midline. Let's see what the period length is. The period is 2 pi over b. Our b value is 2. We have a period length of pi. So my cosine wave will be at its minimum pi to the right and pi to the left. And pi was 1, 2, looks like 1, 2, 3, 4 tick marks. So 1, 2, 3, 4 tick marks. Let's do more. 1, 2, 3, 4. Just for funsies. Halfway between all of those minimums, we will be at a maximum, which will be only 1 above this midline. And fill it in. Everywhere cosine is on its midline, that trig has a value of 0, which means the reciprocal function will be undefined. Of course, all those midline hits will be halfway between a minimum and a maximum. But this is a lot of curve, isn't it? And like we did in the example above, take your blue things, your blue curves, snap them, and turn them upside down. Since I put the midline in green, I'll go ahead and graph this one in purple. But I feel like this equation was overly complicated. I say that because if you look at the blue curve, you can see that it has a maximum on the y-axis. And what kind of function is a maximum on the y? Positive cosine. Which means I could have just called this a positive secant model with no phase shift. We could have just said, in purple, y equals secant of x minus 1. Oh, I forgot the 2. Got to have a 2 in front of that x. Now I screwed it up. Y equals positive secant of 2x, no phase shift, just shift down 1. I mean, look how much nicer that is. But since we're here, let's go ahead and get another equation. Let's get a cosecant model. Cosecant is the reciprocal of sine. Where would a good positive sine wave beginning be? At what x value? Where can we start a positive sine wave? At what x value? No, that's not positive sine. That's positive cosine. Pi over 2 is a minimum, so that's another cosine wave. Pi over 4 would give me a negative sine wave. Negative pi over 4. Wow, that was painful. But yeah, if you start right here, you can start a positive sine wave. So we could start a positive cosecant graph there as well. y equals positive cosecant of 2, and x, since negative pi over 4, plus pi over 4 minus 1. There it is. Wasn't that fun? I don't know, that very last bit kind of was a little torturous, but it's okay. Every nerd has its day.